No, 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 no. Hold on. It's not anyone's wedding, guys. I know half of you already started checking the location, planning where we'll go, and how much biryani you can eat for free. Just relax. You must be wondering whose invitation is this? So, today I made this theme just to make you understand who is the majority element in our life and what kind of roles they play. So, every married guy knows this universal truth. In any decision, there are n number of opinions, but only one opinion that actually matters to them. That's their life partner's opinion. And honestly, there's nothing wrong in that because life becomes very simple. Did you ever experience you are into something, you do n number of research, put some calculations and theories, and finally comes to a conclusion, just saying to yourself, yes, I'm going to do this today. And suddenly you hear a voice saying a big no, and you have to change your decision to no just because there is some message coming from other side that it should be no. And it's very sweet enough. But it's not just someone who appears often. It's someone whose opinion appears more than 50% of the time since the day you met them. And honestly, that's what makes them special. They play the very major role in your life. So, in that case, congratulations, the majority element in your life has already been found. So now, speaking of majority element, today we are learning the majority element problem. We'll figure out how to find majority element in the given array. So let's start. So we are given an array called A and we have set of elements. Majority element is something which occurs more than n by 2 times as discussed. So total number of elements in the given array is 7. So n is going to be 7. So we'll check the occurrences how. Each element is repeating how many times? 2 is repeating 1 time, 1 is 4 times, 5 is repeating 1 time and 4 is repeating again 1 time. Now let's check. Since 1 is appearing more than n by 2 times, don't you think n by 2 is 7 by 2 it's 3 and 4 is greater than 3. Since 1 has been repeated more than n by 2 times, so 1 will be called as majority element. I hope this makes sense now. So let's deep dive into the brute force approaches. Right, so let's look at this brute force approach first. So what is brute force? Like I told you always, you should never underestimate the brute force approach. What comes to your mind, just put it on paper first. Then check like what you can optimize. Okay, let's figure out the time complexity. Whether your code is very like maybe the first time you crack the optimized solution. That also quite possible. But thing is, always try to look a question in very fundamental way. That is it something coming? What do you say? Like very naturally. That's brute force. So I strongly believe in first putting things in brute force approach first, then I'll proceed with optimize. That's how things works. Okay. So you like just think about like what is the basic thing comes to your mind when we want to solve this problem. And I want to really count the number of occurrences of each element. Very simple. I'll pick each element at every time. Then let's say I pick one. Then I will start from this index only. Like index start from take a different marker and say 0, 1, 2, 3, isn't it? This is how our index looks like, right? And as I'm on 0th index now in this case I'm on 0th index, right? 0th index. Now I'm picked 1. I'll check how many times this 1 has been repeated. Like first time at 0th index is there, at 1 index is there, first index, and at 4th index is there, right? So I'm picking one element and I'm checking whether how many times that has been repeated, right? So 3 times. I found the answer is 3, right? When I found the answer is 3, now at the same time I'll check whether is it greater than n by 2. If it is yes, return it. Return the answer. Return what? Return 1. Because 1 is my majority element. Instantly I'm going to return. I don't need to check again the second index. If it is not, then I'll traverse the next index called 1. First index I'll traverse now. Then I'll check again what are the elements. But right now, in this case, it's sorted now. It's like over. We've written the element and we're done with the things. We've done with the question. So this approach, let's put it in code. How the things works. Okay. You have to like think about how much time complexity to take and what are the factors that is going to affect. Like what things you are going to use in your code. Let's do that. Let's say Okay, I'll just to traverse to each element. I need a loop, isn't it? I need a loop, and I'll traverse from where? From 0th index to, right? From 0th index to n minus 1 index, right? You know very well what is 0 and what is n minus 1, right? So I'll write it in different marker. Let's say 0, this is 1, 2, 3, 4. I'll traverse from 0 to 4, not 5, right? So n minus 1. This is very basic. I don't want to get into again the same thing. So this is you. So in this first loop, what you're doing? In this first loop, you're picking one element, right? Picking element. Now in the second loop, what do you want to do? In second loop, you will count the occurrences. Count the occurrences, right? Now my handwriting is very worse. Understand that. I hope you cooperate. So let's say I will traverse from J. Now each element I need to count, right? So I will traverse from again I to n minus 1. Okay. So not I, 0 only, 0 to n minus 1. Because I will start from start. Whenever one element is picked, from start of the index only I am going to scan, like is that same number is present or not, right? So second time you are counting the occurrences, but how you are counting the occurrences? You have to place a condition, right? What condition? A of j, whatever j you picked now, is it matching your a of I? So initially whatever element you are picking, let's say now I picked 1. Now I picked 1. Okay. In first loop I picked 1. In second loop from 0th index I am scanning. 0th index whether my 1 is present or not. How will you check whether 1 is present or not? By giving this condition, right? Well, you're checking like 1 is equals to the picked element or not. Yes, it is present. Then in this case, what I will do? Simply count. Count equals to count plus 1, right? Simple. So you're increasing the count. Now the count increases to 1, right? If the variable here I say count, I'll maintain a variable called count. Now count value is 1, right? Now in the second time, now 0 is over. The second time the loop comes again from first index. Again it checks whether the first index also present the matching the picked element. Yes, right? In this case again you will increase the count. It becomes 2 now, right? Now second index is 2. 2 is it equals to 1, the picked index? No, right? 2 is not equal to 1, so it will skip. 3 is also, third index also won't work. Fourth index again it matches with the picked element, so it count reduces 3 now. The count is 3. Now instantly you are going to check, right? Once you are done with the condition of scanning, we'll instantly check with a condition called if the count value is greater than n by 2. If it is greater than n by 2, then return the, what you need to return? You need to return the picked element, a of I, not a of j or something. A of I, whatever you pick, that element is your majority element now because it is matching your criteria, right? So you're going to that this piece of code works, right? So you tell me now, this piece of code will take how many time complexity? Because you are running I from 0 to n. J also you are running from 0 to n. When you are scanning from initial, right? Initial to the end of the array. When you are picking element, you are also going from 0 to n minus 1. 4 times you go n into n, isn't it? The time complexity is what? Big O of n. Big O of n square, not big O of n, big O of n square, right? So we know big O of n square is what flag? What flag? Red flag. No way we're going to take this, isn't it? No way we're going to take this. What is space complexity, guys? Space complexity is something. Is it? Are you using some extra space to store it or to do some operations? No, right? I is constant, j is constant. It's very all are temporary elements. I mean all are temporary variables, right? And it doesn't take any extra space. So big of 1 is its space complexity for this kind of approach. Now let's look what is optimized approach and how can we optimize this. Okay, we need to optimize, right? Green flag. Let's see. All right, so let's look into the optimized approach now. Okay, so what optimize I can do? So if you are using array data structures, traversing and picking element and counting the number of occurrences, then it's not going to work because array is something you have to use two loops for sure to go through each element one by one, right? We've seen it. So we have to change the data structure now. So array is not going to work. So I'll be using some data structure called HashMap. So how HashMap works? Because HashMap, if you have already known about HashMap, well and good. If not, you have to go through online resources and check what HashMap is. HashMap is one of the data structure that stores in key value pairs. Okay, things are in key value pairs. Let's say I'll pick something called. Let me show you. Pick it now. What I'm trying to do is, for one element, I'll go one by one. Let's say first I'll go to 0th index, right? 0th index is 1. I'll check 1 is having any key or not. No, because HashMap is empty. Let's say I declare a HashMap and first value I'm trying to insert is 1. So 1 is my key and value is my number of occurrences. 1 has been repeated how many times? I don't know right now, because first time I'm picking 1, right? Picking 1 first time. I'm checking 1, is there any value already for this? No, we do not have. So simply I'll just add 1 because this is my first time. Now when I go to first index, like again I'm picking 1 here, right? And I'll be checking like this: 1 has the value or not. Whatever the key 1 has the value or not. Yes, it has. If it is having, then to that value I'll be adding one more 1. Count 1. It becomes 2 now, right? Similarly, I'll go. The next element is 2. My new key is 2 now. But this key, does it have value? No, right? So if it doesn't have any value, then I'll simply add 1 to that. Second time again I'll check. Again 2 comes. Now again it will check like 2 is having any key value or not. Yes, it has. So I'll just simply add 1. 2 is also 2 now. 1 now. Right now I have traversed till this, right? So 2 times 1 has come. 2 times 2 has come. This is the occurrences, right? This is how we calculate. And now the last occurrence is like 1. I'll pick 1 and it will be checking like if the number has that value or not. Yeah, I do have value. To that value I'll again add 1, but that becomes 3, right? So now it looks like this: 1 is 3 times, 2 is 2 times. This is how your HashMap looks. Now in this case, you built your HashMap first, then each element you will traverse and you will say if it is greater than n by 2, if your value is coming as greater than n by 2, then this key is going to be your majority element, isn't it? I hope you got the idea. So that's how HashMap works here. Let's put these things, whatever you discuss, in code. Okay, do that. So let's write the code now. Okay, so I'll be declaring HashMap. So I'll be following a syntax because I need some basic syntax, right? So as I mentioned, it is like what? Key value pair. So keys of what data type and values of what data type we need to write, because keys are elements. Value is nothing but the number of, you're counting the number of occurrences, right? That also going to be an integer because that's a number again. Let's say I write HP. HP is my HashMap name. And I'll say new HashMap. This is how the declaration looks like in Java, by the way. I prefer Java because I am a Java guy. So you can prefer your preferred programming languages, whatever it takes to write. So that's to define. So it's platform independent. Okay, just looking into the idea. Nothing about it. Syntaxes or programming languages. Okay, up to you. So I've declared an HashMap now. So how HashMap looks like, also as I've defined earlier. Let me show that. I'll be parallelly doing this as well. Okay. What I'll do is, okay, I'll pick the. Okay. Now first time I'll run a loop starting from 0 to n minus 1, simple, because I have to iterate one by one element, as I mentioned. While iterating, what are you going to do now? You are building a HashMap. Okay, you need to build a HashMap. You need to build like how many times your elements are repeated, right? You need to do that, right? So you will say, first time you are going to 0th index and you are checking. What you will check, as I already mentioned, you will check whether your HashMap is present, whether your HashMap contains that key or not. Contains key is the method that works, that checks the key, whether that key is already present in your HashMap or not. So when you are checking key is nothing but your element a of I, isn't it? Because you are picking, these are the indexes. A of I, in the sense you are picking the elements now. You are checking whether that element is present as a key in your HashMap or not. Like first time when you say 1, is it present? It will check. No, in this case it fails. It says no, 1 is not present. So if it is not present, then you will do a else case here, by the way. If it is present, what are you going to do? You simply add, you will simply insert. So sp.put is the method we use. So you will say a of I. On this key, you will say hp dot get of a of I, okay, plus 1. What does this mean is, you are telling at this particular index for this key, for one key, you are simply counting one more time, adding one more time. So this, I'll tell you what, else part let me write. If your key is not present, then what you're going to do, you will simply add 1, I told you, right? This is how it works. So this whole thing, let's say I run a loop, this whole loop is nothing but to build a hash map, nothing else. I'm building a hash map. Now how does it works? Let me do a dry run. I'll traverse 0th index. So let me write again a array. So that's very confusing if I do the same thing. This 0, 1, 2, 3, 4. Okay. So I'm traversing 0th index and I'm telling 1. 1, is it containing in my hash map? This is my empty hash map. Do I have 1 already? No, right? I'm first time iterating. So definitely this condition won't work. So it will go to else and it will say, if you do not have 1 at this, but for this particular key, add 1. I'll add 1. Now I'll go to this index called 1. Now this is going. Now I'll pick this element. Now it's going to check whether that element have that key. Do you have any key for this 1 already? Yeah. For 1 you have a value called 1, right? For this particular key, this is the value. This is the key, and these are the values, right? So you're telling yes, 1 is having already a key. So if you're already having a key, simply what you're doing, to that same key you will add 1, because that's how you count the occurrence. I believe it's making sense now. Now if you go to 2 now this 2, it will check 2, does it have any value for 2 key? No, right? So simply if you do not have it, will go to else and it will say for this key make it 1. Now when it comes to second time, now first time is over, now when it comes to second time, 2 again. So it will check hash map whether is present a value called, for this key value called 2. Yes, it has. For that same key, now this first if condition executes, that same key add 1. So hp dot get of a of I is nothing but I'm getting that existing key, to that existing key I'm adding one more 1, like for that count, I'm increasing the count. Now it is 2 again. Now it comes to 1. Now it will check, yeah, it's like now the key is 2, so the existing key I will add one more 1 called 3. So now it looks like 1 is occurring 3 times, 2 is occurring 2 times, isn't it? Now my hash map is ready. So this is how you build a hash map. So this code I have written to building a hash map, that's all. Okay, now you have to check for majority element as well, right? How will you check? Let me scroll down a little bit. Now you have to use one more for loop, because you need to traverse to the hash maps, right? So check your how many keys has how many occurrences, right? So I'll just traverse, like let's say key2, I'll just say like what is my, this is how you traverse, by the way, key set. This is my method. So for each key I will traversing, like how many keys are there, that many times I'll be traversing. This is how it looks, and I'll be simply counting if hp dot get off, again get off what key, I mean get is nothing but I'm getting the value, like how this value I'm checking, whatever the key set I'm picking, whatever the key I'm picking, that value, if it is greater than 1 by 2, then return what key. I'll be returning key now. I'll be returning 1, not I won't return value. How many times it has been occurred, I don't care. I just want what is my majority element. So this is going to be my majority element. And as soon as you do this, simply break it. Do not check for any other keys. It's done, because you are checking for only one majority element, right? That's how your code looks. And this piece of code, for building, it has took how many, you are traversing 0 to n, right? So n times you did. For this piece of code you did n times, and for this piece of code you are doing again maybe n times. But this is not n into n now, this is n plus n, 2n. 2n is nothing but 2 you can ignore because it's constant, so it is like n times only. So do not get confused with n into n and n plus n. N into n we multiply because when we are using nested loops. Are we using nested loop here? These are two different loops, right? This is 0 to n traverse and it's over, it's end here. Again, from start you are traversing from 0 to n. So it's n plus n, not n into n. So this you need to make sure. So n times, so the time complexity for this would be what? For this piece of code, the time complexity is big of n. The space complexity. What is space complexity, do you think? Because you are using a hash map and because this takes extra spaces, this is also big of n. So here the space complexity is big of n because hash map is something the new, you're using occupying some extra memory in your modern system. So that's how big of n. So there might be a case the interviewer might ask you to optimize this space complexity as well. It means that you are not, let's say the interviewer says you are not allowed to use big of n as well. You need to optimize to big of 1. You have to write such a code that you cannot use extra space. So what can be done? That also you need to think about it. There is something called Boyer-Morey algorithm, voting algorithm, that helps you to decrease this as well. I'll be taking one more video to make, to share that idea, how this majority element can be found using that algorithm. Okay, that will reduce this time space complexity as well, because time complexity you have already optimized. It's done. You cannot optimize further for time complexity. Space you can do it. You can do it using that algorithm. I'll be making one more video possibly, and I'll be releasing very soon. So till that, brainstorm once again for this question, and I hope this is a very basic question, but hash map, if you know, it is going to be very easy. Okay, so that's all.
So, what's up? It's time for a reality check. If you have seen my YouTube banner, initially it says arrays weds majority element. You know why? Because we are like arrays, dealing with n number of things every single day, stacking responsibilities, emotions, ideas, and opinions. Out of all those opinions and people who enter our lives, we always end up choosing the right one from the right place. And remember, just like in the algorithm, there can be only one true majority element in your life, not many. Because logically, if someone's presence has been appearing in more than half of your moments since the day you met them, then of course that's the one. So never lose them, hold their hands tight, keep them happy. I hope you enjoy this idea. Until next time, stay tuned. Jai Jagannath.